Hello there, and welcome back to the Sleep Science channel, where we let the mysteries of the cosmos tuck you in for the night. Tonight, you're standing in the cool air of a desert plateau, the kind of place astronomers actually like to climb up to, far away from the glow of city lights. Above you, the sky isn't just dark, it's velvet, a canvas brushed with flecks of white that seem close enough to stir with your fingertip. You squint, waiting for your eyes to adjust, and then you catch it. The faintest smear, almost too shy to announce itself. That little blur is 3I Atlas, a cosmic vagabond, an interstellar comet discovered in the spring of 2020, and it's about to drag you into a story so bizarre you probably won't survive it without at least raising an eyebrow. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And while you're at it, tell me in the comments where you are watching from, and what time of night or morning it happens to be for you right now. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. The comet's name sounds a little technical, like something you'd label a filing cabinet with, but there's drama tucked inside those letters and numbers. 3I means it's the third known interstellar object, following on the heels of 1I Oumuamua, that strange cigar-shaped guest that baffled us in 2017, and 2I Borisov, a much more comet-like wanderer glimpsed in 2019. And then, along came Atlas, discovered by the Asteroid Terrestrial Impact Last Alert System in Hawaii, a survey telescope designed to watch for things that might one day ruin your week by hitting Earth. Instead of an impact threat, though, it revealed a fleeting visitor. One travelling so fast it couldn't possibly be tethered to the sun. It was a drive-by hello from another star system entirely. You watch as the astronomers huddle over their screens, the data coming in grainy but intoxicating. Atlas was faint, even shy, but its trajectory spoke volumes. Its orbit wasn't a neat ellipse like a solar system comet. No, it was hyperbolic, mathematically screaming that it wasn't bound to the sun's gravity. Imagine tossing a stone past a planet and watching it never curve back, just vanishing into the night. That's what the equations revealed. This was a trespasser, a traveller cutting across our backyard on its way to somewhere else entirely. Of course, the history books are full of great sky discoveries. The Halley's Comet observation of 1066 famously made its way into the Bayeux Tapestry, stitched above the heads of nervous medieval warriors. The quirky tidbit, though, is that in Japan that same year, monks recorded the comet as an omen of famine, while a Persian scholar insisted it was a dragon. Historians still argue whether societies feared the comet itself or just used it as cosmic shorthand for their anxieties. And now here you are, centuries later, staring at another comet that doesn't even belong to our solar system, wondering what stories people will stitch about this one. The first images of Atlas weren't spectacular. Nothing like a glowing streak across the night sky. It looked like a fuzzy cotton ball in the darkness. Yet astronomers knew that faintness could mean size, distance, or even material. You lean closer, feeling almost sheepish for being excited about a blurry smudge. Still, when you remind yourself this smudge was born under a different sun, from a disk of dust and ice orbiting some alien star, it suddenly feels monumental. You're not looking at just a comet, you're looking at a souvenir from someone else's planetary nursery. The early measurements made Atlas seem smaller than expected, only a few hundred meters across, fragile and volatile. You picture it not as a solid rock, but as a kind of cosmic snowball, porous and prone to crumbling. It carried dust and ices not native to our neighbourhood, possibly storing molecules older than Earth itself. And though you can't quite smell space, sorry to disappoint sci-fi fans, you imagine it reeking faintly of methanol and cyanide, the sour, acrid perfume of interstellar chemistry. Not exactly something you'd spritz on your wrist before a date, unless your date was an alien with very strange taste. As the nights pass, astronomers grow increasingly giddy. The comet brightens, flaring like it's trying to get noticed. The more they look, the more irregularities they see. Its light curve, the pattern of its brightness, fluctuates in odd ways, suggesting it might be tumbling, braking, or venting gas unpredictably. You squint at the charts, tracing those jagged ups and downs, as if watching a heart monitor for a patient who refuses to follow medical advice. Every spike and dip tells a story, though not a story anyone yet understands. You can almost feel the impatience in the observatories. A comet this fleeting is a race against time. Each night matters because soon it'll be too faint, too far, slipping back into the abyss where no telescope can follow. Observers squeeze in exposures, trade notes across continents, and upload data in bleary-eyed marathons. Somewhere in that frenzy you catch the whisper. Could this object hold shocking possibilities about what kinds of debris drift between stars? Could its quirks hint at processes we've never witnessed? The whole thing feels fragile, like watching a guest walk through a crowded party, pause just long enough to sip a drink, and then step back into the night. You don't know where they came from, you don't know where they're going, but you can't shake the feeling that something essential just brushed past you. Of course, not everyone is enchanted. Some researchers shrug, saying that interstellar objects should be expected, given how planetary systems fling debris during their chaotic youth. In their view, Atlas is just one of countless cosmic snowballs wandering aimlessly, and the real surprise is simply that we've gotten good enough at spotting them. But you know how scientists are. Put 10 in a room and you'll get 11 opinions. Historians still argue whether Copernicus hesitated to publish his heliocentric model out of fear or out of a professional caution. Astronomers today argue whether 3i Atlas is unusual or just the first faint ripple of a statistical wave about to crash. Still, you feel the thrill of perspective. Each blurry image of Atlas is a handshake across light years, a fragment of another star's leftovers now tangled in our story. And while it won't linger long, its discovery proves something. The universe is more restless than we realized. The night sky isn't a static dome, it's a bustling highway, and every so often something crosses our lane. So you stand under that desert sky, the air crisp against your skin, and you let your gaze rest on that faint, flickering smudge. Somewhere inside its icy pores lies a record of alien chemistry. Somewhere in its jagged orbit lies the memory of a star you'll never see. And for a moment, with the silence pressing in, you let yourself feel small in the best possible way. Small but connected, a passenger on Girth watching another traveller pass by, two ships meeting in the boundless night. You keep your eyes on that faint smear of light, letting the awareness settle in. This object is not from here. Every comet you've ever heard about, Halley, Hale-Bopp, Neowise, those were born in the Oort cloud or the Kuiper belt, icy regions at the edge of our solar system. But 3i Atlas is an exile, slipping across our neighbourhood from somewhere else entirely. Its trajectory doesn't bend gently into a loop around the sun, instead it stretches into infinity, a mathematical line that will never close. You trace its hyperbolic arc with your imagination, watching it carve through our system like a knife through fabric. Hyperbolic orbits sound fancy, but they're essentially the cosmic equivalent of a no-return ticket. Objects in our solar system tend to move in ellipses, which are bound paths. But this one, it was screaming outsider from the first calculations. You picture the astronomers, coffee-fueled and wide-eyed, entering the data into orbital models and watching the curve break free from the sun's grasp. That moment must have been exhilarating, like realizing you've spotted a traveller from a land you didn't even know existed. There's a certain humility in that realization. You've been taught to think of the solar system as a kind of cozy, walled garden, with planets circling obediently around the sun. But here comes 3i Atlas, bursting through the fence, reminding you that the cosmos doesn't play by your metaphors. It makes you wonder how many of these interstellar visitors have come and gone unnoticed, back before telescopes were sharp enough to pick them out. Historians still argue whether ancient skywatchers might have glimpsed such travellers but lumped them in with regular comets. After all, Chinese astronomers recorded comets with surprising detail as early as the Han Dynasty. But whether they knew one might have been interstellar, that's anyone's guess. A quirky tidbit here. In the late 1800s, a French astronomer named Camille Flammarion speculated that comets could cross between star systems, ferrying life in their icy bellies. He wasn't just being poetic, he genuinely thought these icy wanderers might scatter seeds of biology from one world to another. Most of his colleagues rolled their eyes, but here you are, staring at an actual interstellar comet, realizing maybe Flammarion was playing the long game in that argument. Atlas isn't alone in rewriting the map. You think back to what Oumuamua discovered in 2017, which zipped through so quickly astronomers barely had time to aim their instruments. That one had a path that also shouted hyperbolic, but its shape and motion were so odd that theories still swirl about what it really was. Some call it a shard from a shredded planet. Others lean on the fringe idea that it could have been alien tech. And now Atlas, though more comet-like, confirms that visitors aren't one-off freak events. They're part of the galactic background noise. There's a historical parallel you can't resist here. In 1492, Columbus reached the Caribbean and realised, very incorrectly, that he'd found a shortcut to Asia. What he actually revealed was the start of a new awareness, that there were other continents, other people, whole realities beyond Europe's map. In a softer, more cosmic sense, that's what interstellar comets are doing to your sense of home. They're showing that our solar system isn't an isolated island. It's a port city on a galactic trade route, with strangers dropping in uninvited. But the orbit of Atlas isn't just an idle curiosity, it's a clue. By plotting its backward path, astronomers can try to guess where it came from. Of course, that's easier said than done. Every star in the galaxy is in motion, tugged around by gravity, so tracing a comet's route is like watching a firefly zip through a forest and trying to guess which tree it started from. Historians still argue whether backward orbit calculations for 2I Borisov actually point to a specific birthplace or whether it's all just educated speculation. The same ambiguity surrounds Atlas. We can say it came from out there, but pinning down the exact parent star feels like chasing a rumour. Still, you can't resist the thought experiment. Somewhere, light years away, there's a star system where Atlas was born. Maybe it was flung outwards during the chaotic birth of that system's planets. Picture a world with thick clouds of methane, or an icy exoplanet circling in darkness. Atlas could have once been part of that environment, carrying chemical fingerprints of alien weather. And then, after some gravitational encounter, a gas giant playing billiards, it was hurled outward, doomed to wander for millions of years until it blundered into your telescope's view. As you drift deeper into this story, the sense of scale grows dizzying. Atlas travelled perhaps millions of years through empty space before finding its way here. That's longer than humanity has existed. It means this object began its journey long before the pyramids, before the Ice Age, before Homo sapiens even had a name for themselves. And tonight, you're the one staring at it. That's the cosmic version of someone handing you a postcard that was mailed before the invention of stamps. It makes you laugh softly at your own routines. You worry about being 5 minutes late to a meeting, yet here's Atlas, arriving after a trek that spanned eons, and nobody scolds it. Cosmic wanderers get a pass on punctuality. They've earned it, but still you notice the discomfort in the astronomer's tone. Interstellar objects remind them how little control we really have. Most celestial bodies are predictable. Planets, asteroids, and comets cycle back like clockwork. But these outsiders? They appear with no warning, blaze across the sky, and vanish, leaving only questions. That unpredictability has a way of nudging your brain awake, even when you're supposed to be drifting towards sleep. You imagine future generations treating interstellar objects as routine discoveries. Kids might grow up scrolling through holographic images of comets from other stars the way you swipe past cat videos. But for now, in this brief era, everyone feels like a thunderbolt, like the cosmos is reminding you it's bigger, stranger, and more restless than you dared to dream. And so you keep your eyes on the trajectory, that clean, hyperbolic slash through the solar system's neat orbits. You picture it not just as a line on a graph, but as a path through your imagination. It's an invitation to think of space not as a closed box, but as a web of connections, threads linking suns across the galaxy. Atlas isn't trespassing, it's just passing through, one of countless pilgrims on a journey you'll never fully map. You tilt your head slightly as the numbers scroll across the observatory screens, graphs tracing brightness columns levels that rise, dip, then stutter again. Measuring the light of 3I Atlas isn't as simple as pointing a telescope and snapping a picture. The comet plays tricks with every exposure. Astronomers call this the light curve, the record of how an object brightens and dims over time. For most comets, those fluctuations follow a pattern as the sun warms their surfaces, causing jets of gas and dust to puff outward. But Atlas behaves like an unreliable narrator, one that promises consistency only to yank the rug away when you least expect it. You squint along with the scientists, imagining yourself perched beside them in the control room, sipping bad coffee from a chipped mug. On one night, the comet looks faint, subdued, like a shy guest in the corner of a party. Then a day later it brightens dramatically, glowing several magnitudes stronger, as though it suddenly decided to hog the dance floor. But almost as quickly, it dims again. The jagged lines on the graph look like a child's attempt at handwriting, chaotic, endearing, but impossible to decipher at first glance. The process of measuring brightness has a touch of ritual to it. You point the telescope, capture images, subtract background light, compare to reference stars whose magnitudes are well known, and then calculate how bright the comet truly appears. Each step feels painstaking, yet still the results refuse to settle. Atlas flickers unpredictably, like a candle in the wind, and if a comet is nothing but ice and dust, shouldn't it obey physics with a bit more discipline? Here's where the quirky tidbit sneaks in. Some researchers joke that Atlas must be cosplaying as different types of comets on different nights, changing its apparent activity like it was auditioning for roles. And while that's not exactly in the peer-reviewed journals, the humour masks a real puzzle. What could cause such inconsistent brightness? Tumbling rotation? Irregular jets? Or perhaps fragments peeling off the nucleus in fits and starts? Historians still argue whether earlier interstellar observations, like with One Eye or Oumuamua, showed similar inconsistencies, or whether we simply didn't have enough data to notice. You lean back, letting your mind wander to older moments in skywatching history. In 1577, the Danish astronomer Tycho Brahe tracked a bright comet with enough precision to prove that comets moved beyond Earth's atmosphere, not within it as many philosophers had assumed. That was a turning point. Comets were not atmospheric vapours, but celestial bodies, and now, here you are, with Atlas challenging another assumption. Not that comets exist, but that they behave in predictable, rule-bound ways. Tycho had his sextants and quadrants. Today's astronomers have CCD cameras and software, but the sense of bewilderment remains timeless. You watch as a group of graduate students mutter at their laptops, trying to run models of Atlas's rotation. If the comet is spinning chaotically, sunlight might heat its surfaces unevenly, causing sporadic outbursts of gas. Imagine a frozen orange tumbling through space, each rotation exposing a different patch of ice to warmth, each patch venting at its own rate. That could explain the light curve's jittery heartbeat. But of course, models can only do so much when the object itself is hundreds of millions of kilometers away. There's also the question of what Atlas is made of. Its brightness might not just reflect size or activity, it might hinge on surface of its composition. Some ices sublimate more easily than others. Carbon monoxide, for instance, vaporizes at far colder temperatures than water ice. If Atlas carried an exotic mixture of ices, its outbursts could switch on and off depending on which chemicals were exposed, and that idea makes you shiver slightly. Because if its chemistry is unlike most solar system comets, then Atlas carries the fingerprint of a star system entirely foreign to you. You imagine for a moment that the light curve is a kind of Morse code blinking out messages as the comet whirls along. Brightness up, brightness down, a flicker here, a pause there. Of course, it's natural to anthropomorphize when you're staring at irregular patterns. It's the same impulse that makes people see faces in clouds, but it does make you smile, imagining an alien civilization sending postcards by comet light, and Earth's astronomers completely missing the point because they're too busy adjusting exposure times. Still, the data has weight. Astronomers feed it into dynamic models, hoping to constrain the comet's size. The irregular light suggests the nucleus might be elongated, not spherical, with jagged cliffs or craters that reflect sunlight unevenly. That wouldn't be unusual for a comet. After all, Rosetta's famous subject, Sanctuarium of Gerasimenko, looked like a cosmic rubber duck. But the more unusual the behaviour, the more you're forced to ask whether interstellar comets play by slightly different rules. The truth is that every flicker of light, however faint, is valuable. You feel a kind of reverence imagining the photons. They left the comet's surface, scattered across tens of millions of kilometres, passed through Earth's atmosphere, and landed on a detector as a faint dot. That dot is then transformed into numbers, into graphs, into arguments. Somewhere between the photon's birth and the debate over its meaning lies the fragile miracle of human curiosity, and then you feel the urgency. Atlas is moving fast, slipping away from the sun's glare. Every night brings a new chance to grab data, and every night lost is one more blank page in the record. Astronomers set alarms for ungodly hours, wrestle with cloudy skies, and sometimes get nothing but static. Yet when the conditions line up, the reward is a burst of clarity, another stretch of brightness curve added to the jagged line. You imagine the relief, the cheers muffled in observatories, when the comet cooperates for just a moment. Of course, the frustration runs parallel. The more data they collect, the stranger the picture becomes. Atlas refuses to smooth itself into a neat model. Instead, its light curve sprawls in messy defiance, like graffiti scrawled across the laws of comet behaviour. And maybe that's the point. Maybe interstellar visitors aren't here to conform to expectations. They are here to remind you that the cosmos thrives on exceptions, on irregularities, on stories too strange to fit the mould. So you let your gaze return to the imagined graph, those jagged peaks and valleys, and you feel oddly comforted. The comet may be unpredictable, but so are you, and so is life. Maybe that irregular light isn't a problem to solve, but a cosmic lullaby, a reminder that not everything needs to settle into neat rhythms. Sometimes the universe just flickers, and your role is simply to watch, to wonder, and to accept that unpredictability can be beautiful. You drift closer to the thought of Atlas, not just as a faint smudge on a graph, but as an actual body out there, a lump of ice and dust slowly turning in the void. If you could stand near it, ignoring of course the impossibility of breathing or surviving out there, you'd notice its surface reflecting sunlight in a way that feels slightly off. Astronomers studying its albedo, that is, its reflectivity, quickly realised it was unusually pale compared to most comets we've catalogued in our solar system. Instead of the dark, charcoal-like crusts common on local comets, Atlas seemed to shimmer faintly, a little brighter, as though covered in frost that hadn't yet had time to bake into soot. Normally, comets wear their history like scars. Solar radiation and countless passes near the sun darken them, baking volatiles away and leaving behind crusts of organic-rich dust that turn their surfaces blacker than asphalt. That's why many comets have such low albedo values, often reflecting only a few % of the sunlight that strikes them. But Atlas, having spent eons in deep interstellar exile, hadn't suffered those same sunburns. It looked fresher, more pristine, almost like snow laid down the night before, untouched by footsteps. You let that image settle in, a cosmic snowball carrying the untarnished story of another star system's youth. Somewhere billions of years ago, this object was formed, then flung outward, and it has since wandered in deep freeze, shielded from the scorching trials of close stellar encounters. The fact that it appears pale is less a mystery and more a time capsule, a hint that what you're seeing is unprocessed material, unweathered by countless solar flybys. A quirky tidbit adds flavour here. When early astronomers first described comets in the 17th century, they often called them hairy stars because their diffuse tails looked fuzzy. Some even insisted comets were made of a kind of celestial cotton. Historians still argue whether those descriptions were metaphors or genuine attempts at physical explanation, but it's hard not to chuckle at the thought. If only they'd known that centuries later, we'd be squinting at a comet from another star and describing it as unusually pale, as if we'd finally discovered the universe's answer to lint. You can't help but compare Atlas to other known comets. Halley's Comet, for instance, is notoriously dark, reflecting only about 4% of the light that hits it. The Rosetta mission revealed Comet 67P to be similarly grimy, with a surface darker than coal dust. And yet Atlas, in its spectral measurements, didn't quite fit that mold. Its reflectivity suggested surfaces laced with volatile ices, less crusty, more fragile. That difference whispers of a birthplace under conditions not identical to our own solar nursery. Perhaps its parent star system was colder, or perhaps the chemistry of its protoplanetary disk allowed different compounds to dominate. And that's the part that makes your mind spin gently toward the speculative. If Atlas looks different, maybe other interstellar objects will too. What if the diversity of cometary surfaces is as broad as the diversity of stars themselves? You can picture astronomers 100 years from now cataloguing pale comets, black comets, red comets, each a sample from a different star system, each with its own geological accent. The Milky Way becomes not just a sea of suns, but a gallery of icy artifacts drifting between them. There's a historical echo to this thought. When Galileo first turned his telescope to the moon in 1609, he saw not the perfect heavenly sphere imagined by philosophers, but a scarred, mountainous surface. That realization that other worlds bore marks of geology, not divine perfection, was a seismic shift in worldview. Similarly, looking at Atlas's pale surface is a reminder that other star systems too create their own messy, diverse leftovers. The cosmos isn't uniform, it's textured, irregular, and richer than the neat diagrams in your school books. Of course, astronomers argue over what that pale reflectivity truly means. Some suggest it's simply a matter of observing bias, that maybe we caught Atlas at a stage in its outgassing that made it appear brighter than it really was. Others point out that interstellar space is hardly empty. Radiation, cosmic rays, and dust collisions could alter a comet's surface over time. Historians still argue whether early records of Borisov's surface brightness were underestimated for similar reasons, and the same uncertainty hangs over Atlas. Was it really pale, or just performing a temporary trick under our instrument's gaze? For your imagination, though, the pale surface adds a delicious strangeness. You picture a cosmic ice cube, glittering faintly in sunlight, tumbling along with jagged facets catching rays at odd angles. If you could scoop it into your hand, maybe it would crunch like fresh snow. Though knowing cometary chemistry, it would probably fizz violently as volatile gases burst free. More like holding a shaken soda than a snowball. Not exactly the kind of thing you'd want in your hot cocoa. The pale albedo also hints at fragility, and that sets a certain tension humming beneath your drowsy fascination. Objects like this may not survive their encounters with the sun. They crumble, fracture, dissolve into tails of dust and vapour, leaving only memories and orbital traces behind. In that sense, every glimpse of Atlas is precious. You're watching not just a visitor, but a disappearing act. A magician halfway through the trick, the pale shimmer a last glow before vanishing. And yet, as you linger on the thought, the strangeness becomes soothing. There's comfort in knowing that even out here, across the immensity of interstellar travel, fragility persists. Not everything in the universe is hard and indestructible. Some things are delicate, fleeting, pale, and easily undone. Maybe that's why Atlas tugs at you. Not because it's alien, but because it mirrors your own brief, fragile glow against the backdrop of eternity. So you picture yourself drifting beside it, feeling no weight, no time, just the faint sparkle of sunlight off its fresh surface. It doesn't shout its presence, it whispers. And maybe that's why it lulls you now, urging you towards sleep with its soft shimmer, reminding you that even the faintest glow can travel light years, cross system, and still arrive with its story intact. You follow Atlas in your mind's eye as it streaks through space, and the first thing you notice isn't just its path, it's its speed. Regular comets, the homegrown kind that orbit the Sun, tend to shuffle along at velocities between 10 and 70 kilometers per second, depending on their eccentric orbits and how close they swing to the star. But 3i Atlas is no local commuter. It barrels through at a pace so fast that even the Sun can't pin it down. That velocity is the signature of its freedom, the proof that it doesn't belong to our solar system. You imagine the astronomers crunching the numbers, watching them spit out orbital solutions that clearly screamed, "This one's just passing bare." Hyperbolic velocity isn't just about bragging rights. It's a clue. The faster an object moves, the less likely it is to have been nudged into that path by a nearby planet. A comet kicked from our Oort cloud, for instance, could get a high-energy fling, but its orbit would still remain tied to the Sun. Atlas, though, entered at a speed too great to be explained by local dynamics. You picture it like a car zooming onto a roundabout but refusing to merge into traffic, just cutting straight across and roaring off into another lane. No wonder astronomers raise their eyebrows. Comparisons to earlier interstellar visitors feel inevitable. Oumuamua, the 2017 Enigma, tore through the inner solar system at about 87 kilometers per second, leaving barely enough time for telescopes to swing around and study it. 2 years later, Borisov appeared, its trajectory clear, its speed impressive but comet-like. Atlas's velocity sits in that strange family portrait, reinforcing the idea that interstellar visitors aren't rare anomalies, but rather routine drifters we've only just learned to notice. Historians still argue whether earlier fast-moving comets logged in the 19th century might secretly have been interstellar too, simply misclassified before orbital mechanics matured. You pause here, because speed has a way of shrinking cosmic scales into human metaphors. Imagine travelling at Atlas's pace. In 1 second, you'd cross the distance between Paris and London. In less than half a minute, you'd lap Earth entirely. Yet for all its breakneck motion, the comet looks calm through telescopes, a smudge gliding in silence. No roar of engines, no sonic boom. Space, it seems, hides velocity inside stillness. There's a quirky tidbit hidden in cometary lore. In the 1700s, Edmund Halley, the very same Halley who gave his name to the famous comet, suggested that comets might sometimes move so fast that they could even collide with Earth, bringing catastrophic floods or fires. His theory was based less on precise science and more on a flair for cosmic drama, but it cemented the image of comets as dangerous speed demons. Today, Atlas reminds you that Halley wasn't entirely wrong. These objects do come in fast, unpredictable, and sometimes fragment spectacular show. They just don't usually line up for the big scary collision, at least not yet. As you let the thought sink in, you begin to sense the paradox of cosmic velocity. On one hand, it makes Atlas uncatchable. There's no spacecraft waiting on the launch pad with the capacity to intercept it in time. On the other hand, it's precisely that speed that gives you confidence the comet isn't a threat. By the time Earth even registers its presence, it's already on its way out. You could almost laugh at the irony. The very thing that makes it unobservable up close also makes it harmless. Astronomers watch its course with obsessive care, calculating its closest approach and ultimate escape. It dives toward the sun, arcs gracefully, and then swings back outward, like a skier carving through a mountain valley. But the skier's pace never slackens. Atlas never slows enough to be trapped. You imagine the sun reaching out with its gravity, tugging desperately, only for the comet to shrug off the attempt and keep flying. If celestial bodies could wink, Atlas would do so as it left, leaving the sun muttering about ungrateful house guests. You remember that in ancient times, speed itself was terrifying because people had no frame of reference for it. When Halley's comet blazed across the sky in 1910, its rapid sweep left many thinking Earth might plunge through its poisonous tail. Newspapers sold comet pills and anti-comet umbrellas to anxious buyers. The quirky human urge to turn awe into consumerism is hard to miss. Historians still argue whether that panic was more about scientific illiteracy or simply savvy marketing, but either way, it shows how speed and strangeness have always rattled the human imagination. Tonight, though, Atlas's velocity feels less like a threat and more like a lullaby of motion. You picture yourself riding alongside it, weightless, the stars wheeling by in slow grandeur, even though you're moving faster than any jet, faster than any rocket humanity has ever built. The paradox deepens. At such velocity, time seems to stretch out, not compress. You feel yourself sinking into that stillness, a passenger on a cosmic bullet train with no stations and no destination but forward. The astronomers keep logging data, their charts filled with numbers trailing after Atlas's path. Each value is another reminder of how fleeting the encounter really is. Unlike Halley's comet, which returns every 76 years, Atlas will never pass by again. It's a one-time meeting, a handshake across interstellar space, then goodbye. And in that goodbye lies the heart of the mystery. The comet moves fast not just through your skies, but through your imagination, sparking questions that linger long after the object itself has vanished into darkness. So you let yourself feel the hum of that velocity, not as something to fear, but as something to marvel at. The comet's pace is proof of its story, proof of its exile, proof of the restless universe you're part of. And as it rushes past, you realize you don't need to chase it. You just need to notice it, to let its speed remind you how vast and lively the cosmos really is. You picture the tail of Atlas stretching out like a ribbon behind it, sunlight teasing gas and dust away from the nucleus in a glittering stream. Normally, a comet's tail behaves like a loyal banner, pointing consistently away from the sun thanks to the push of solar radiation and the solar wind. But with Atlas, astronomers noticed something peculiar. The dust wasn't playing by the usual rules. Instead of a smooth, predictable fan, its tail flickered, bent, and sometimes seemed to fray at the edges as if invisible fingers were tugging at it. You can almost imagine the comet muttering, "I styled my hair for this journey, and now the cosmos is messing it up." Dust is supposed to be the simple part of cometary physics. Gas jets erupt as the sun heats volatile ices, dragging grains of dust outward into space. Those grains scatter sunlight, creating the glowing tails visible even to the naked eye. But when Atlas was tracked night after night, the dust distribution shifted in ways that left even seasoned observers scratching their heads. Sometimes the tail looked strong and full, other times weak and fragmented, as though the comet couldn't decide whether to shed its material or cling tightly to it. You can imagine the astronomers huddled over their spectral plots, trying to model what could cause such fickle behavior. Was the nucleus already cracking apart, venting dust in spurts like a soda can shaken before opening? Or was the dust itself different? Perhaps finer or charged in a way that made it respond oddly to the solar wind? Historians still argue whether a similar dust anomaly was present with Borisov, or whether the data quality simply wasn't high enough to reveal it. A quirky tidbit floats up here. In the 9th century, astronomer Friedrich Bessel proposed that comet tails might be formed not by particles but by a kind of mysterious repulsive force from the sun. It wasn't until later that scientists confirmed radiation pressure and solar wind as the culprits, but Bessel's idea persisted long enough to inspire all sorts of fantastical theories, including the notion that comets were semi-transparent ghostly apparitions rather than physical objects. In a funny way, Atlas's odd tail would have fit perfectly into that ghostly narrative. You let yourself imagine being closer, trailing just behind the comet. Grains of dust, each smaller than a speck of sand, would be drifting outward, lit faintly by the sun. It would accelerate, racing ahead into the diffuse tail, while others would linger near the nucleus, forming temporary clumps before dispersing. The whole scene would look chaotic, like watching snowflakes swirl in gusts of wind. Yet despite the chaos, there's a kind of beauty in it, a randomness that makes you realise this is no rigid machine, but a fragile body improvising its way through space. And the improvisation has consequences. The unpredictability of the dust tail made it harder for astronomers to measure Atlas's mass and activity level. Dust tails are like fingerprints, revealing the size of grains and the rate at which the comet is shedding material. With Atlas behaving erratically, those fingerprints kept smudging, refusing to leave a clear record. It's as though the comet was deliberately blurring its own biography, keeping its origins hidden just a little longer. You think about the comets in history that surprised observers with their dust. In 1811, the so-called Great Comet displayed a tail visible for nearly 9 months. Long enough for Napoleon's soldiers to call it a good omen. On the opposite end of the spectrum, Comet Kohoutek in 1973 was hyped as the comet of the century, but fizzled into disappointment, its tail faint and underwhelming. Historians still argue whether Kohoutek's failure was due to media exaggeration or genuine miscalculations of its activity. Compared to those highs and lows, Atlas seems less concerned with reputation and more with subtle mischief, showing a tail that refuses to behave in textbook fashion. The dust also raises the question of survival. A chaotic tail often signals structural weakness, a comet beginning to fragment under solar stress. And indeed, Atlas eventually did break apart. But even in these earlier stages, the dust was hinting at its fragility. You can almost see it trembling as it raced forward, grains flying loose like sparks from a campfire. It makes you realise how delicate these visitors really are. Fragile snowballs barely held together, sprinting through space at impossible speeds. But if you tilt your perspective, the erratic tail isn't a flaw at all. It's a gift. Each flicker, each irregular puff of dust carries new information. By studying how the grains scatter and disperse, astronomers learn about the size distribution, about the forces at play, about the chemistry locked inside the ice. It's like trying to read a book while the pages are being ripped out and tossed into the wind. Difficult, yes, but still possible if you catch enough fragments. And so you settle into the strangeness, imagining the comet's tail as a kind of cosmic smoke signal. Its message isn't neat or easily translated, but it's undeniably there. The dust refuses to behave, and in doing so it whispers secrets about its alien birthplace. You don't need the answers tonight. The flickering mystery itself is enough to lull you into a kind of soft awe. Out here, even dust can be dramatic, and sometimes that drama is the only lullaby you need. You lean in closer, as though the comet might reveal its secrets if you squint hard enough. The flickering dust trails were strange enough, but then came the chemistry, the kind of revelation that makes astronomers sit up straighter and rub their temples. When light from the sun strikes a comet, it excites the molecules in its coma, the fuzzy envelope surrounding the nucleus, and those molecules glow at specific wavelengths. By running that glow through spectrographs, astronomers can decode what chemicals are present. With Atlas, the spectra hinted at the familiar water vapour, carbon dioxide, but also teased at traces that looked ever so slightly unusual. Not unheard of, but definitely eyebrow-raising. Think about that. You're staring at molecules that once froze solid under a different star's light, perhaps billions of years ago, and now they're lighting up under our sun. That's not just science, it's archaeology on a galactic scale. Each molecule is a shard of pottery, a fossil, a relic from an alien kitchen. And while most comets in our solar system serve the same cocktail of ices, H2O, CO2, CO, methanol, Atlas seemed to spike the drink with hints of something extra. Subtle ratios that didn't quite line up with local recipes. Quirky tidbit bubbles up here. In the 1970s, scientists briefly considered the idea that comets could smell. Astronauts returning from spacewalks reported that their suits carried odd aromas after exposure to vacuum, hints of ozone, burnt steak, even metallic sweetness. The comet smell was later described as a mix of rotten eggs, bitter almonds, dierskiss and horse stables, thanks to compounds like hydrogen sulfide and ammonia. Imagine trying to bottle that as perfume. Eau de interstellar. Not exactly a bestseller at department stores. The chemistry of Atlas became one of its biggest fascinations. Some astronomers noted that its coma seemed unusually rich in carbon-bearing compounds, while others argued that the data were too noisy to be definitive. Historians still argue whether similar oddities were glimpsed in Borisov's spectra, or if Atlas genuinely represented something stranger. The debate is the heartbeat of science. One team claims novelty, another urges caution, and in the middle lies a comet shrugging at everyone. You picture how these molecules formed. Billions of years ago, in a cloud of dust and gas circling a newborn star, tiny grains clumped together, coated in ices. Some of those ices may have been laced with organic compounds, the same carbon-rich chemistry that seeded early Earth. Then, after gravitational pinball with larger planets, one chunk was tossed outward, away from its home forever. It wandered frozen, inert, until chance brought it near our sun, and in that moment its ices thawed, releasing whispers of alien chemistry. The thought makes you dizzy, because it means that in Atlas's coma, you are literally sampling another star system. You're breathing, figuratively, on molecules that were never meant to reach here. It's like finding a message in a bottle, drifting across not just an ocean, but an entire galaxy. Of course, the message isn't written in English or any human language. It's encoded in spectral lines, faint hums of light at wavelengths you can't even see without a machine. Still, the message is there. I came from elsewhere. Here's what my birthplace was made of. That birthplace might not look anything like Earth's solar system. Maybe it was a red dwarf with flares blasting constantly, or a young star surrounded by a dense disk, rich in exotic carbon compounds. The chemistry of Atlas, especially if it truly was skewed compared to local comets, is a postcard from that environment. You can almost imagine the star, dim or bright, warming a disk of dust while Atlas slowly took shape on the cold outskirts before being exiled. You also recall how scientists debate panspermia, the idea that life's building blocks, or even microbes, could hitch rides on comets across interstellar space. Most dismiss the idea as unlikely, given the brutal conditions. But the chemistry of Atlas fuels those late-night whispers. If interstellar comets carry organic precursors, then they're not just wanderers, they're delivery systems. Historians still argue whether early Earth's water and organics came largely from comets or from asteroids, but the presence of alien molecules in Atlas makes you wonder, how many times has life's recipe been mailed across the cosmos in icy packages? It's funny how the smallest details can feel the most profound. We talk about comets as kilometre-sized icebergs, fragile and temporary, yet it's the microscopic molecules escaping into space that change our perspective. Each photon of light absorbed and re-emitted by those molecules tells you something about chemistry billions of years and billions of kilometres removed from your daily life. You sit at your desk, maybe sipping tea, while a faint glow in space whispers the story of another sun. You imagine being close enough to Atlas to see the chemistry at work. Gas jets spurt from fissures in the surface, invisible in the vacuum, until sunlight ignites them into faint glows. If you could hold a vial of that beer, you'd be holding alien ices sublimated into breath. Of course, you wouldn't live long enough to appreciate it. Hydrogen cyanide isn't exactly good for your lungs, but the fantasy lingers because even danger feels oddly poetic when it's packaged as interstellar chemistry. And so the comet drifts on, its coma swelling with strange molecules, its tail scattering fragments of alien chemistry across the solar system. You realise you'll never get a complete answer, never hold a direct sample of Atlas in your hand, but maybe that's okay. Maybe the mystery is the point, that lull between questions and answers, that gentle hum of the unknown. Tonight, as you think about alien ices vaporizing into light, You let the curiosity itself be your comfort. The cosmos doesn't have to hand you every secret. Sometimes it just has to hand you a comet. You let your mind drift with the notion that Atlas might not be a solitary wanderer. What if it's one of many? The idea feels both thrilling and unsettling. A whole family of travellers slipping silently across the galaxy, most too faint to be caught by even our sharpest surveys. For every one we've spotted, Oumuamua, Borisov, and now Atlas, there could be thousands, maybe millions, gliding unnoticed through the dark, passing by Earth without a whisper. The thought lingers, and you picture interstellar comets as shoals of fish moving through cosmic waters, with our solar system just one reef they sometimes brush against. Astronomers have begun to suspect this isn't just fanciful. Statistical models suggest that if we've already caught 3 interstellar objects in just a few years, the sky must be teeming with them. The surveys that found Atlas weren't even designed specifically for catching interstellar debris. They were tuned to spot asteroids that might slam into Earth. That's like buying security cameras for your house and instead capturing footage of a parade of strangers cutting through your yard. It raises the possibility that the galaxy is littered with debris from planetary systems, and we've only now opened our eyes to it. Historically, humanity has always underestimated the traffic around us. In the 18th century, European explorers believed the Pacific might contain only a handful of scattered islands. Then voyages revealed entire archipelagos, chains of islands teeming with cultures and life. Historians still argue whether those early explorers truly believed in an empty ocean or simply lacked imagination. The same debate now stretches into the stars. Did we once believe interstellar comets were impossibly rare, or were we simply blind to them until our tools improved? The quirky tidbit comes from an astronomer who once described interstellar comets as galactic litter, scraps flung out during planetary formation, drifting endlessly like cosmic trash. Not the most flattering metaphor, but it makes you chuckle. Trash or treasure depends on perspective. After all, one person's discarded coffee cup can be another person's art project. In the same way, an ejected ice ball might seem like debris to its home system, but becomes priceless evidence once it enters ours. You imagine the process of their exile. A young planetary system forms, planets shifting and migrating chaotically, gravitationally booting chunks of ice and rock outward. Some fall into their star, some slam into planets, but countless others are tossed beyond the star's gravitational leash. Those fragments become interstellar wanderers doomed to eternal journeys between suns. Atlas was one such refugee, and if it happened there, it must happen everywhere. Every star system flinging its leftovers into the galactic sea. The mental picture grows vivid. Billions of comets wandering the Milky Way like spores, drifting from one stellar neighborhood to another. Some pass silently, invisible. A rare few wander close enough to stars like ours to light up and reveal themselves. We've probably missed thousands already. Their faint streaks lost in the noise of the night sky. The 3 we've caught might be the tip of a mountain range hidden beneath the ocean. The implications ripple outward. If interstellar objects are common, then so too are opportunities for exchange, chemical, geological, even biological. Those frozen ices could carry organic compounds from one planetary nursery to another, scattering the seeds of complexity across unimaginable distances. That doesn't mean panspermia is proven, but the more debris we find, the harder it is to dismiss the idea entirely. Life might not arise in isolation, it might ride the galactic currents on icy rafts. You recall another historical shift in perspective. When Louis Pasteur showed that microorganisms float invisibly in the air, people suddenly realized they were never alone, even when the air seemed empty. The discovery of interstellar comets feels similar. You stare at the sky and understand that it's not empty at all. It's alive with invisible motion, with fragments of alien systems silently drifting by, just beyond the reach of your unaided eyes. Historians still argue whether the first hints of Oumuamua should have convinced us sooner, or whether skepticism was the healthy choice. Either way, the pattern now is undeniable. You let yourself imagine standing at the edge of a dark meadow looking up. For centuries, you believed the stars were fixed and remote, unreachable pinpoints. Then you learn that not only do those stars have planets, but some of those planets throw off debris that wanders right through your sky. Suddenly, the stars don't feel far anymore. They're sending you samples, whether they mean to or not. And what if we could catch one? Not just photograph it, but launch a spacecraft to intercept it, sample its ices, and bring them back. Future missions are already being dreamed up, rapid response probes designed to chase down interstellar visitors. If Atlas is part of a family, then sooner or later, one of its cousins might linger long enough to be intercepted. Imagine the thrill of opening a container back on Earth to reveal chunks of alien ice, still fizzing with chemicals that formed under another sun. That's not just science fiction anymore, it's a question of timing and readiness. But tonight, lying back under your blanket of stars, you don't need the spacecraft, or the data, or even the answers. It's enough to picture a galaxy alive with travelers, each comet a frozen emissary from a story too distant to fully grasp. Atlas might be only one, but it proves a family exists. And as you breathe slowly, eyelids heavy, you let the thought of countless wanderers soothe you. The cosmos is busy, the highways are full, and you're lucky enough to have caught a glimpse of traffic passing by. You can't think about Atlas without your mind drifting back to the first time we realized something from beyond the solar system had paid us a visit. In 2017, telescopes picked up a faint, fast-moving object cutting across the inner system, and the world learned the name Oumuamua, Hawaiian for scout or messenger. It was a poetic christening for an object that looked nothing like what anyone expected. While Atlas behaved like a recognizable comet, tails, outgassing fragments, Oumuamua was a master of confusion, a cosmic enigma wrapped in a tumbling shard. Its brightness flickered in ways that suggested a bizarrely elongated or flattened shape, some saying cigar-like, others pancake-flat. No dust, no coma, no tail, just a silent, rapidly spinning interloper. The comparison is irresistible. Where Atlas presents itself as fragile, shedding dust and dissolving under the sun's heat, Oumuamua seemed tough, aloof, even defiant. One fell apart under pressure, the other refused to display even the most basic cometary manners. Yet both shared that same hyperbolic orbit, that same message written in their trajectories. We do not belong here. Astronomers struggled, as they always do, to explain. Was Oumuamua a comet that had lost its ices long ago, leaving only a desiccated husk? Or was it a shard from a planet torn apart, the jagged relic of a catastrophic event in another star system? The debates still haven't ended, and you can almost hear the frustration in scholarly tones. Historians still argue whether Oumuamua was truly unique or whether we simply caught it at the wrong moment. Its refusal to show a tail left many unconvinced that it was a comet at all, leading to wild suggestions that bordered on science fiction. Here's where the quirky tidbit comes in. Harvard astronomer Avi Loeb famously proposed that Oumuamua might have been a piece of alien technology, perhaps a light sail drifting between stars. The idea sparked headlines, podcasts, and countless late-night arguments. Most of the scientific community dismissed it as unnecessary speculation. But Loeb's willingness to say the quiet part out loud that we might have just seen alien hardware still lingers in the public imagination. And you have to admit, it adds a certain thrill when you look up at the night sky and wonder if one of those faint streaks was someone else's cast-off gadget. Against that backdrop, Atlas feels almost comforting. It behaves badly, yes, but it behaves within the realm of cometary physics. It has tails, it fragments, it shows the molecular signatures of volatile ices. In a way, Atlas is the normal sibling in a family of weirdos. Less mysterious than Oumuamua, but no less profound. And yet, when placed side by side, the two paint a richer picture. Interstellar visitors come in flavours. Some are dusty snowballs, some are dry shards, some perhaps are things we can't yet categorise. You can't help but see a historical echo here. When Europeans first encountered fossils of dinosaurs in the 19th century, they were baffled by bones that didn't fit any known species. Some scientists insisted the animals must still exist in unexplored corners of the Earth. Others argued the bones belonged to multiple species mashed together. Historians still argue whether those early misinterpretations slowed down or actually energized paleontology. Similarly, with interstellar objects, we may be fumbling at first, unsure what we're seeing, mislabeling, overhyping, underhyping, but the very confusion is fueling a new era of discovery. And then there's the psychological impact. When Oumuamua zipped past, humanity got its first reality check. The galaxy isn't just out there, distant and separate. Its leftovers literally fly through our skies. By the time Atlas appeared, astronomers had already recalibrated, ready to expect more visitors. You imagine being a future stargazer, scrolling through a catalogue of 1,000 interstellar comets, each with a nickname and an origins known star. Oumuamua and Atlas will be the legends, the first few scouts that cracked open our sense of cosmic neighbourhood. It's almost funny to think that before 2017, we had no confirmed interstellar visitors, and now we're practically debating their personalities. Oumuamua, the aloof mystery. Borisov, the reliable textbook comet from another star. Atlas, the fragile but flamboyant performer, crumbling as it made its entrance. The galaxy feels less like an empty expanse and more like a stage full of characters, each with quirks, flaws and stories. And maybe that's what keeps you awake in the best way, the realization that our solar system isn't isolated at all. Debris from other suns is dropping by, unannounced but undeniable, leaving us clues about planetary systems we may never visit directly. It's not just that we've seen 3, it's that those 3 are all so different, suggesting a whole spectrum of wanderers waiting their turn. So tonight, when you think about Atlas, you don't just see a pale, flickering comet. You see it standing in conversation with Oumuamua, like 2 travellers at a cosmic rest stop, one grizzled and enigmatic, the other fragile but vivid. Their paths may never cross again, but for a fleeting moment, they've both crossed yours, and that is enough to remind you that the galaxy is alive with stories, and you've only just begun to overhear them. You lie back with your hands folded under your head and let the thought creep in. What if Atlas, or Oumuamua before it, wasn't just a natural wanderer? The notion sounds like something whispered in the corner of a late-night dorm room conversation, equal parts thrilling and ridiculous. Still, you can't ignore how quickly the question arises when anything strange crosses our skies. Is it possible this is artificial? A probe? A message? A relic from someone else's civilization? The silence of space almost dares you to ask. For Atlas, the evidence leans solidly toward natural origins. It crumbled, outgassed, carried dust, all the hallmarks of a genuine comet. But the memory of Oumuamua lingers like an unsolved riddle. Its elongated shape, its non-gravitational acceleration, its refusal to sprout a cometary tail, those quirks stirred the pot. And while most scientists chalked it up to odd geometry and unfamiliar physics, the public imagination leapt eagerly to aliens. You picture headlines shouting cigar-shaped UFO and chuckle softly. Historians still argue whether the media frenzy helped spark interest in astronomy, or just distracted from sober research. A quirky tidbit comes to mind. Back in the 1960s, when the first pulsars were discovered, their perfectly regular radio signals were so bizarre that astronomers nicknamed the source LGM, for Little Green Men. They didn't actually believe aliens were sending Morse code across the cosmos, but the joke reveals how tempting it is to fill gaps in understanding with stories of intelligence. Once they realized pulsars were spinning neutron stars, the alien hypothesis quietly faded. Maybe in time, Oumuamua's strangeness will fade into a similarly tidy explanation. Still, it's hard to dismiss the thrill. You imagine an alien civilization, millions of years ahead of us, designing probes small and silent, meant to wander between stars. They wouldn't announce themselves with blinking lights or radio chatter. They'd look ordinary, hiding in plain sight, because what better disguise than to resemble the natural debris already swarming the galaxy? A stealth fleet of probes, camouflaged as comets and asteroids, drifting through systems like ours without notice. It's a concept that's equal parts eerie and comforting. The reality, of course, is that natural explanations keep winning. Atlas fragmented spectacularly. If it were alien tech, it was shoddily built. But even so, scientists don't roll their eyes too hard at the what-if questions. Speculation has always been part of discovery. When Galileo first saw Saturn through his telescope, he thought it had ears. He couldn't make sense of the rings. When Percival Lowell mapped canals on Mars in the early 1900s, he was projecting human engineering onto natural patterns. Historians still argue whether Lowell's Martian fantasies hindered or helped planetary science, but there's no denying they inspired a generation. Maybe our alien probe jokes about Oumuamua and Atlas will inspire future missions with more serious intent. You let yourself dwell in the ambiguity. On one hand, it seems absurd to imagine aliens using fragile ice balls as probes. On the other, there's something poetic about it, sending your message not as a loud broadcast, but as a quiet fragment of your world, hurled into interstellar space to be found eons later. Even if Atlas is just a natural comet, it still functions that way. A bottle tossed into the galactic ocean, carrying chemistry from another shore. Whether intentional or accidental, the effect is the same. And then you consider the silence. If aliens did send probes, why haven't they signaled? Why haven't we intercepted anything unambiguously artificial? That question lingers like background static in every SETI meeting. Maybe the answer is simple: the universe is big, time is long, and civilizations are rare. Or maybe the probes are out there, passing us by unnoticed because we haven't learned how to recognize them. Historians still argue whether the Fermi paradox, that gap between probability and evidence, is really a paradox at all, or just a reflection of our impatience. For now, the data on Atlas doesn't scream probe. Its chemistry, its tail, its fragmentation all paint the picture of a natural comet. But the fun lies in entertaining the possibility, even if only for a heartbeat before drifting back to reason. Because when you're lying under the stars, it's impossible not to wonder if someone else is lying under theirs, watching their own interstellar comets, and thinking the same question: what if? So you let the thought linger, not as an answer, but as a lullaby. The silence of space is deep, but so is the imagination. Whether Atlas is a messenger by design or by accident, it has delivered something precious, a reminder that you're not only a passenger of Earth, but also a participant in a galaxy alive with motion, mystery, and maybe, just maybe, company. You close your eyes and picture Atlas as it drifts closer to the sun, fragile and glittering, and then you hear the crack. Not a sound in reality, of course, space is silent, but in your imagination the comet snaps like brittle glass under strain. The great fragmentation of 3I Atlas was both expected and heartbreaking. Comets are notoriously fragile, cosmic snowballs held together by little more than gravity and hope. As sunlight warms them, pressure builds inside fissures, and eventually the nucleus can no longer bear the stress. For Atlas, the stress was fatal. Instead of sailing gracefully through its close approach, it shattered into a scatter of icy shards, a family reunion no comet really wants. Astronomers watched the breakup unfold in real time, telescopes capturing the nucleus stretching, elongating, then breaking into distinct pieces. At first it looked like one fragment, then two, then dozens. Each chunk reflected sunlight in its own way, giving the illusion of a small swarm travelling together. You can imagine the scene as a cosmic breadcrumb trail, bits of interstellar ice marking the path like sparks thrown from a firework. The once singular traveller had become a procession. The spectacle brought both joy and frustration. On the one hand, fragmentation revealed the comet's weakness and gave astronomers a chance to study how interstellar material crumbles under solar stress. On the other hand, the breakup meant the nucleus, its pristine, intact core, was lost forever. It's a little like finding a priceless artifact, only to watch it crumble to dust the moment you touch it. You can almost hear the collective groan echoing through observatories worldwide. Of course, this isn't the first time a comet's grand entrance ended in pieces. In 1846, comet 3D Biela famously split into two visible fragments, sparking fear that Earth might later collide with one. By 1872, the comet was gone entirely, its debris instead producing a spectacular meteor shower. Historians still argue whether the 1872 Andromedid storm was solely Biela's remains, or a combination of multiple lost comets. The quirky tidbit: newspaper editors at the time gleefully described Biela's demise as suicide by sunlight. Atlas would have appreciated the dramatic headline. As the fragments of Atlas drifted apart, each one seemed to carry its own story. Some were large enough to glow visibly, others likely dissolved almost immediately, vaporized into dust too fine to track. For astronomers, this scattering offered rare data points. How fast were the pieces separating? How long would they last? What did the breakup reveal about the comet's internal structure? Each fragment became a laboratory, a cross-section of alien geology ripped open for inspection. You imagine floating among those fragments, each chunk tumbling silently in space. Some would look jagged, freshly torn, others would sparkle with exposed ice catching the sun's rays. If you could scoop one up, you'd be holding material older than Earth itself, frozen relics that once orbited another star. The romance of the thought makes you sigh, even as you realise the tragedy. You'll never touch them, never taste their chemistry directly. They'll disperse, fade, and vanish into the night. The breakup also raised philosophical questions. Was Atlas more valuable whole or as fragments? Whole, it represented a singular traveller, a complete relic from another system. Fragmented, it offered multiple glimpses into its interior, more opportunities for study. You can almost hear the astronomers debating like art curators. Do you prefer the intact statue or the shattered pieces that reveal the sculptor's chisel marks? Historians still argue whether the Rosetta mission benefited more from observing intact 67P or whether a fragmenting comet would have yielded even richer science. And yet, there's a strange beauty in watching something fall apart gracefully. Think of autumn leaves scattering in the wind, or fireworks dissolving into trails of sparks. Atlas's fragmentation was catastrophic, yes, but it was also mesmerizing. The comet didn't simply vanish, it transformed, multiplying into a constellation of temporary companions. For a few nights, the sky displayed not one visitor but dozens, each fragment a whisper of the whole. You wonder too about the symbolism. Here was a traveller from another star journeying for millions of years, only to shatter when it finally encountered ours. It's almost poetic, endurance followed by fragility, persistence ending in vulnerability. Maybe that's what makes it resonate so deeply. The comet's demise is a reminder that even the most ancient wanderers can crumble when exposed to new warmth. Still, there were sun's marches on. Each fragment was tracked, measured, catalogued, its fading glow logged meticulously. Even in death, Atlas contributed knowledge. Its breakup showed that interstellar objects can behave not just strangely but familiarly. Its demise mirrored that of many local comets, and that, perhaps, is the most comforting lesson. In their fragility, in their endings, interstellar comets are not so different from our own. So you close your eyes and imagine those shards drifting away, slowly scattering into darkness. The Great Fragmentation isn't just a loss, it's a gift of many small lights instead of one. Like dreams breaking into fragments when you wake, Atlas leaves pieces behind, brief, fleeting, but enough to remind you that even broken things can be beautiful. You sit with the image of Atlas, breaking into shards, and naturally your thoughts wander to its path, where it came from and where it's going. The orbit of an interstellar comet is like a breadcrumb trail across the galaxy. By tracing its arc backward, astronomers can try to guess the region of space it might have crossed before brushing against our sun. For Atlas, the orbital reconstruction suggested it came swooping in from far above the plane of the solar system, a trajectory so steep and hyperbolic that it practically announced its foreign birth. You imagine the astronomers plotting dots on their charts, connecting lines that stretch not just through space but back through time. Reconstructing such a path is a bit like trying to figure out where a leaf floating down a river originally fell. The water swirls, currents shift, winds blow, and after a while the trail becomes impossible to untangle. Space is no calmer. Stars orbit the galaxy, gravitational nudges accumulate, and the comet itself has been on the road for millions, maybe billions of years. Still, the models suggest rough galactic neighbourhoods. Some studies pointed toward the constellation Lyra, others to Cassiopeia, but the truth is slippery. Historians still argue whether backward orbit tracing of objects like Borisov or Oumuamua really tells us anything solid, or whether it's just educated guesswork dressed up in equations, a quirky tidbit to lighten the math. In the Middle Ages, astrologers believed comets had specific hometowns too, but instead of constellations, they thought comets emerged from vapours on Earth, rising up through the atmosphere to ignite in the heavens. The idea persisted for centuries despite observational contradictions. It's amusing to think that we've gone from attributing comets to swamp gases to tracing them across galactic spiral arms. Progress, in its sleepy, stumbling way, always arrives. You picture Atlas's journey through the galaxy. It may have crossed near other stars, maybe even skimmed through the outer debris belts of alien systems. Imagine the comet drifting past an exoplanet swathed in methane haze, or sailing silently through the outskirts of a system with twin suns. Each pass could have left subtle scars on its orbit, tiny gravitational nudges that steered it toward us. The idea that you're looking at an object touched by multiple stellar neighbourhoods makes it feel less like a comet and more like a pilgrim, carrying stamps from many ports of call. Tracing its orbit also reveals something about our place in the galaxy. The sun isn't fixed. It drifts around the Milky Way at about 220 kilometers per second, tugging Earth and the other planets along like luggage on a cosmic carousel. That means interstellar comets don't just stumble into us. We're also moving toward them. like two ships intersecting on vast invisible currents. When you realise that, the encounter with Atlas feels less random and more like a natural crossing of paths. Astronomers debate whether the comet originated in a stable planetary system or whether it was flung out violently during planetary migration. Our own solar system, in its youth, likely ejected trillions of icy bodies as Jupiter and Saturn shifted positions. Atlas could be one such exile from another system's chaos, a relic of its own version of Jupiter. Historians still argue whether giant planets are essential to tossing comets outward, or if smaller systems could also produce exiles like Atlas. Each trajectory traced is another piece in that puzzle. For you, the allure isn't the precision of the math, but the story it tells. Imagine standing in Atlas's birthplace, looking up at its parent star billions of years ago. Perhaps you'd see a sky tinted red from a cooler sun, or maybe a brilliant white glare from a star hotter than ours. Somewhere in that sky, Atlas formed on the cold outskirts destined for exile, now after a journey longer than human history. It has brushed past Earth's skies before fading again into the galactic night. That story, birth, exile, encounter, departure, feels less like orbital mechanics and more like mythology. And what of its future path? After leaving our solar system, Atlas will keep going, forever unbound. It won't circle back, it won't stop, it will carry its fragments outward, scattering dust that will one day be indistinguishable from the interstellar medium. Maybe, eons from now, its shards will wander close to another star, sparking curiosity in eyes not human. The thought makes you grin. Perhaps right now, on some distant world, another species is puzzling over their own three-eye Atlas, wondering where it came from and what it means. The orbit is more than numbers, it's a bridge. By tracing it backward, we glance at alien neighbourhoods. By tracing it forward, we imagine alien observers. Either way, the comet connects us to a wide galaxy, and as you drift towards sleep, you let that connection cradle you. Your life is a short orbit, fragile and fleeting, but it still arcs into the vastness, brushing against mysteries older and larger than you'll ever fully know. You linger with the idea of tracing Atlas's orbit, and soon the next realization creeps in. If we've seen 3 interstellar visitors in just a few short years, Oumuamua, Borisov, and Atlas, then maybe they aren't rare jewels at all. Maybe they're common, shockingly common. The math begins to whisper unsettling possibilities. Astronomers have started calculating the density of such objects in the galaxy, and the numbers don't point to a handful, they point to billions. Imagine that. For every star, a swarm of icy cast-offs drifting freely, invisible until they wander close enough to light up. The statistical shivers come from simple reasoning. Our telescopes, even the wide-field survey ones, only cover a tiny slice of the sky at any moment. They are not always on, and even when they are, interstellar objects like Atlas spend only a short time bright enough to be noticed. Catching 3 in quick succession suggests the true population must be enormous, or else we've been absurdly lucky. And while luck has its charm, astronomers don't like leaning on it too much. They'd rather admit the galaxy is busier than they thought. History reminds you this isn't the first time science underestimated abundance. In the 17th century, when Antonia van Leeuwenhoek peered through his early microscopes and found animalcules swimming in a drop of water, the world was stunned by the sheer density of unseen life. Historians still argue whether his contemporaries believed him immediately or dismissed him as eccentric, but either way, the discovery shattered the illusion of emptiness. Something similar is happening with interstellar comets. What once seemed void is now a crowded thoroughfare. The quirky tidbit is that some researchers have even suggested Earth itself may have been struck by interstellar debris before, perhaps delivering exotic isotopes or molecules into our geology without anyone realizing. Our planet, in that sense, might already carry scars or souvenirs from countless unseen visitors. The idea is speculative, but it adds a playful twist. Maybe the ground beneath your feet is sprinkled with the faintest dust of alien comets, too faint to recognize but real all the same. Statistical models point towards staggering numbers. One study estimated there could be on the order of 10 to 96 interstellar objects larger than 100 meters roaming the Milky Way. That's not a typo, that's 100 trillion. Not all of them will pass close to stars, but the sheer scale suggests our solar system is constantly crossed by these ghosts, with only a fraction ever being noticed. When you let that sink in, you realize that we don't live in a quiet neighborhood at all. We live at a galactic crossroads, traffic humming around us at all times, and yet, because of their faintness, most will never be detected. Only the brightest, the ones that outgas dramatically like Atlas, or flare strangely like Oumuamua will snag our attention. The rest pass silently, their presence betrayed only in probability tables. It's like realizing you're standing at the edge of a vast highway, and the 3 cars you've seen in the last hour are part of a stream stretching endlessly in both directions. You just can't see the others through the fog. The implications are profound. If interstellar objects are common, then every star system is constantly shedding its material into the galaxy. The Milky Way isn't a collection of isolated households, it's a messy neighbourhood where everyone's laundry gets flung into the street. And if icy fragments can carry organics, or even simple water, then the seeds of chemistry are being distributed galaxy-wide, over and over again. Historians still argue whether panspermia deserves scientific credibility, but with every new visitor, the case for a cosmic exchange strengthens. You imagine an alien astronomer on a distant world pointing a telescope outward and catching sight of one of our own cast-offs, an icy shard from the Oort cloud, tumbling into their system. They might run the same calculations, whisper the same astonished words. It came from elsewhere. Suddenly the galaxy doesn't feel like a scatter of stars separated by emptiness. It feels like a network, stitched together by debris constantly moving between systems. And so the shiver you feel is twofold. There's awe at the immensity, the abundance, the revelation that space is crowded in ways we didn't realize, but there's also humility, a reminder that we're not special in our isolation. We're part of the flow, both sending and receiving fragments in a grand exchange that predates humanity and will outlast it. As you exhale, the statistics themselves begin to feel like a lullaby. Numbers so large they dissolve into a hum, like waves crashing too far away to hear clearly. Billions, trillions, countless travelers passing by. You close your eyes and let the thought wash over you. The galaxy isn't silent, it isn't empty. It's alive with motion, full of hidden wanderers, each one a quiet story slipping through the night. You sit with the math still echoing in your head, billions of interstellar objects drifting invisibly, and suddenly you realize what that means. Every one of them is a sample, a postcard, a care package from another planetary system. The fragments of Atlas tumbling like crumbs from a cosmic loaf aren't just bits of ice and dust. They're evidence of geology and chemistry that unfolded under a foreign sun. You could think of each shard as a tiny mineral exhibit, shipped across interstellar space free of charge, waiting for us to pick it up and read its story. Imagine if we could catch one. You picture robotic spacecraft swooping in to grab a fragment, sealing it inside a protective capsule, and then ferrying it home. When opened in a lab, that piece of comet would reveal isotopic ratios, chemical fingerprints, maybe even exotic minerals not found in our solar system. It would be the closest thing to holding another star system in your hands, like shaking hands across light years. The very thought makes your pulse quicken before it drifts back into the soothing rhythm of wonder. The idea isn't new. Throughout history, humanity has stumbled into alien samples long before we knew what they were. Meteorites, for example, have been falling on Earth for eons. Ancient cultures often treated them as sacred gifts from the gods. One-iron dagger found in King Tutankhamun's tomb was forged from meteoritic iron, the quirky tidbit. That dagger predates the Iron Age by centuries, meaning Egyptians were literally wielding space metal before they figured out how to smelt their own. Historians still argue whether the dagger was symbolic or practical, but the fact remains, extraterrestrial fragments have always fascinated us. Atlas, however, represents the next level, not just extraterrestrial, but extrasolar. You imagine walking through a museum of interstellar debris, each display case holding a sample from a different star system. One fragment might show a water to deuterium ratio, slightly different from Earth's, hinting at a cooler birthplace. Another might reveal ices rich in carbon monoxide, suggesting a disk around a hotter, more massive star. Another might carry dust grains older than the Milky Way itself, relics of the galaxies that merged to form ours. Each fragment is both alien and familiar, like dialects of the same universal language. Atlas's fragments, in particular, invite speculation. When the comet broke apart, it exposed fresh interior ice that had been shielded from cosmic rays for millions of years. Studying such pristine material, even from a distance, offers a window into conditions we could never otherwise observe. You picture the astronomers squinting at spectral data, tracing faint absorption lines and whispering, "This ratio doesn't match local comets." Each fragment is like a word in a half-erased letter, forcing you to fill in the gaps with imagination. You also think of how fragments can travel far beyond their parent comet's life. Dust streams persist long after the nucleus disintegrates, creating meteor showers when Earth crosses their paths. That's what happened with Comet Biela in the 19th century. Its breakup spawning storms of meteors decades later. Historians still argue whether the spectacular Andromeda displays of the 1800s were solely Biela's handiwork, but the connection is hard to ignore. Now you wonder, could fragments of Atlas one day intersect Earth's orbit, sprinkling our skies with the ashes of another star system? The idea gives you chills, the good kind. The possibility of planetary system postcards goes beyond geology. If interstellar fragments carry organics, as many comets in our system do, they might also deliver molecules that hint at alien prebiotic chemistry. Not life itself perhaps, but the raw ingredients. What if Atlas carried amino acids? What if its dust contained sugars or nuclear-based precursors? Even a single detection would reshape how we think about life's odds across the galaxy. Suddenly, the fragments aren't just souvenirs, they're whispers of possibility. Of course, caution tempers the excitement. The fragments are faint, distant, and dispersing. Without a spacecraft on standby, we'll never capture them directly. All we have are telescopic glimmers, spectral hints, and the aching awareness of what might have been. Historians still argue whether our technology will ever be nimble enough to chase down such fleeting visitors, or whether we'll always be stuck watching them vanish, like fireworks we can never touch. But the dream persists. You imagine future generations building fast-launch probes, ready to intercept the next Atlas-like visitor. One day, children might hold rocks that formed under a completely different sun, their textbooks filled with chemical signatures from half a dozen star systems. The Museum of Planetary Postcards will grow, and Earth will finally feel less like an isolated island and more like one port among many. For now, though, you let the fragments drift in your mind like snowflakes melting on your palm. Each one carries a story you'll never fully read, but that doesn't lessen the beauty. In fact, it heightens it. You don't need the whole letter. A torn scrap is enough to know that someone, somewhere was writing. And so you breathe deeply, soothed by the thought, Atlas didn't just shatter, it delivered a gift. Tiny postcards from another world scattered gently across the dark. You let those postcards drift away in your imagination, and then another thought slips in, colder, heavier. What if Atlas had been bigger? What if instead of a fragile snowball crumbling like sponge sugar under sunlight, it had been a kilometre-wide boulder of interstellar rock, dense and unyielding, barreling toward Earth? The galaxy's traffic isn't all gentle. Some of those billions of wanderers must be massive, fast and careless. And the nightmare math behind that possibility is enough to make even the most relaxed stargazer sit up straighter. Consider this, an object the size of Mount Everest, travelling at 60 kilometers per second, about the speed of Atlas, wouldn't just land, it would obliterate. The energy release would dwarf any nuclear arsenal on Earth, creating shockwaves strong enough to flatten continents. Local comets and asteroids already carry such risk, but interstellar ones raise the stakes. They come faster, leaving less warning time, and their orbits are harder to predict. You can't prepare for what you don't see until it's already screaming through your atmosphere. There's history to remind you how small impacts change the world. 66 million years ago, a rock about 10 kilometers wide slammed into what is now the Yucatan Peninsula, ending the age of dinosaurs. Firestorms, global cooling, extinction, the works. Historians still argue whether the Chicxulub impact alone caused the extinctions or if it worked in tandem with massive volcanic eruptions, but the moral of the story is clear. Space rocks mean business. And that was a local rock, flung from our own solar system's backyard. Imagine one arriving with the added boost of interstellar velocity. The quirky tidbit here. In the 1800s, some writers genuinely feared that comets were hollow, filled with gas, and could engulf Earth like a cotton ball swallowing a pea. One French philosopher, François Arago, even calculated how long humanity might survive inside a comet's atmosphere. Spoiler, not long. While laughable today, the idea speaks to an ancient dread, comets as threats, not curiosities. Atlas, though gentle in its passing, reignites that old anxiety in modern form. If small visitors exist, and large ones might too, astronomers run simulations of what such a collision might look like. An interstellar object with even modest mass could release energies equivalent to millions of megatons of TNT. Cities, nations, ecosystems, all gone in an instant. And because of their high speed, interstellar impactors can't be easily deflected by the methods we dream of. Gravity tractors, nudging rockets, even nuclear pushes. You'd have to spot them early, years in advance, and that's assuming your telescopes catch them at all. You picture the headlines, Alien Comet 30 days out. The countdown would be relentless, the panic global. Scientists would scramble, governments would fumble, and somewhere a child would still ask if they had to do homework that night. The absurdity of daily life crashing against cosmic doom makes you smile, even as the scenario leaves a chill behind. Humanity's talent for denial might outlast the object itself. And yet, you remind yourself, the odds are small. The galaxy is busy, yes, but space is vast. The chance of a large interstellar object hitting Earth is low enough that you can safely let it fade into background worry, like the possibility of a lightning strike. Still, the numbers don't lie. Sooner or later, Earth will be struck again by something local or interstellar. The question isn't if, but when. Historians still argue whether ancient myths of floods and firestorms were seeded by early impacts, woven into cultural memory long before geology gave us the evidence. But fear isn't the only response. There's also perspective. You live on a tiny planet orbiting an average star in a crowded galaxy, and yet here you are, aware of the risks, capable of modelling them, even preparing, at least in theory, to meet them. That awareness is its own kind of shield. Knowledge may not stop the sky from falling, but it softens the helplessness. You're not just prey waiting for a predator, you're a species learning to read the shadows overhead. And so the nightmare fades into a quieter thought. Yes, interstellar rocks could be deadly, but they are also rare, and their rarity gives you time to marvel instead of panic. Tonight, Atlas is not a threat, it's a teacher, a reminder that fragility and danger coexist with beauty. You pull the blanket a little tighter, letting the fear dissolve into the hum of possibility. The same highways that deliver hazards also deliver wonders, and both are worth watching. You breathe slowly, Oni, letting your pulse settle. The galaxy's dangers aren't here to terrify you, they're here to remind you of scale, of humility, of the fragile miracle of being alive right now. Atlas could have been a nightmare. Instead, it was a fleeting spark, a pale shimmer, a visitor that asked you to look up and think bigger. And that, in its quiet way, is far more powerful than fear. You picture the astronomers at their stations, faces illuminated by the cold glow of monitors, racing against time as Atlas drifts farther and farther away. Observing an interstellar visitor is like trying to photograph a stranger sprinting past your window. You get only a handful of seconds, and then they're gone. For Atlas, the window was even narrower because its fragile nucleus began to fragment and fade, dimming before the instruments could gather all the data they wanted. Every night mattered, every hour mattered. Telescopes across the world and even in orbit turned toward this ghost, chasing a visitor that would never return. The urgency creates its own kind of electricity. Astronomers coordinated across continents, handing the baton from one night sky to the next, trying to keep the comet in view around the clock. Hawaii to Chile to Spain to South Africa, the relay of lenses and mirrors kept the chase alive. You imagine bleary-eyed grad students emailing each other in the dead of night. Hot dish at magnitude 10.3. Tail looks unstable again. The rhythm is frantic but oddly soothing to picture, like a global heartbeat pulsing in sync with the comet's passage. History offers plenty of examples of such races. In 1910, Halley's Comet sparked a frenzy, with scientists scrambling to measure its tail as Earth passed directly through it. Panic spread in newspapers. People bought comet pills and gas masks to protect themselves from imagined poisons. Historians still argue whether the panic was widespread or mostly a media invention. But the chase itself was real. Telescopes everywhere turned skyward, knowing the moment would not return for another 76 years. The quirky tidbit: some entrepreneurs sold anti-comet umbrellas, promising protection from falling debris. Atlas, in comparison, gave us no fear, only urgency, a quieter, more disciplined chase. You think about the instruments themselves. Modern surveys like Pan-STARRS and Atlas, the telescope system, not the comet, are designed to scan wide fields quickly, looking for motion against the fixed stars. That's how interstellar visitors are caught. They don't follow the slow arcs of asteroids, they streak across images, their speed and direction betraying their foreignness. Once spotted, bigger telescopes take over, dissecting light into spectra, measuring tails, snapping high-resolution images. For Atlas, every spectrum was a treasure, every image a sliver of biography. But the Comet didn't make it easy. Its faintness tested the limits of detectors. Clouds rolled in at the worst times. Sometimes it dipped too close to twilight, hidden in the sun's glare. You imagine the frustration, nights of preparation, hours of setup, only for the target to fade into daylight or be swallowed by weather. And yet astronomers persisted. Because the alternative, letting an interstellar object slip by unrecorded, was unthinkable. This urgency highlights a bigger truth. Astronomy is as much about patience as it is about panic. You can wait decades for Halley to return or centuries for rare alignments, but when an interstellar visitor appears, you drop everything. It's cosmic triage. Atlas demanded attention, and in that way, it united observatories worldwide in a kind of impromptu campaign. For a few weeks at least, everyone was chasing the same ghost. You recall how even ordinary comets have sparked similar scrambles. In 1994, astronomers rushed to study Comet Shoemaker-Levy 9 as it shattered and collided with Jupiter. The event was a once-in-a-lifetime opportunity, and telescopes from Chile to Arizona turned their eyes to the giant planet. Historians still argue whether that event reshaped planetary science more than any other single comet observation. With Atlas, the stakes felt different. Not planetary impact, but interstellar mystery. But the same fever ran through the scientific community. There's something comforting in that image. A species scattered across continents, languages, and time zones, united by the simple act of looking up. It makes you wonder if one day, an alien species somewhere else is doing the same thing, their telescopes chasing one of our ejected comets as it flashes briefly through their skies. The symmetry of the thought is enough to soften your chest, like a gentle exhale you didn't realize you were holding. And so you lie there, imagining the ticking of clocks in observatories worldwide, the hush of domes sliding open, the whir of motors tracking faint points of light. The astronomers know the urgency, but you, drifting into the cadence of their work, feel only the calm reassurance of their dedication. Someone is always watching. Someone is always chasing the ghosts. And even if Atlas fades before the full story is told, its brief glow has already connected eyes and hearts across the planet. You let that soothe you. The chase isn't just about data, it's about wonder shared. The comet was fleeting, but the act of pursuit, the collaboration, the urgency, the long nights under cold skies, that endures. And as Atlas slips into the dark, the memory of the chase lingers, a soft hum in the background of human curiosity, steady as a lullaby. The comet fades, the telescopes close their domes, and you find yourself staring at the idea of wandering itself. Atlas isn't just a naked body on a hyperbolic orbit, it's a mirror for the human condition. To wander without a home, to drift endlessly with no return ticket, is both terrifying and strangely beautiful. You imagine yourself as the comet, flung from your birthplace, carrying fragments of memory, but never again touching the world that birthed you. In that sense, Atlas becomes less a comet and more a metaphor, a pilgrim with no shrine, a traveller who belongs everywhere and nowhere at once. Philosophy has always been drawn to wanderers. The Greeks told stories of Odysseus, a man destined to wander oceans for decades before finally returning home. In medieval Europe, pilgrims set out on foot for Santiago de Compostela or Canterbury, believing that the journey itself was the blessing. Historians still argue whether those pilgrimages were acts of devotion or opportunities for trade and cultural exchange, but the resonance is clear. Humanity has always found meaning in motion. Atlas, drifting past our sun, is an interstellar pilgrim. Its meaning lies not in arrival, but in passage. The quirky tidbit that makes you smile: in the 1600s, comet sightings were sometimes linked to wandering souls. Some believed comets were the spirits of the restless dead, doomed to drift until their sins were absolved. It's a poetic misstep, but you can't deny the imagery: bright, fleeting visitors with no place to land. Atlas, if judged by that folklore, would be the ultimate restless spirit, condemned to wander not just Earth's skies but the whole galaxy. And yet there's solace in belonging to no single place. You think of nomadic cultures, from the Bedouins in desert caravans to the reindeer herders of Siberia, who find home in movement itself. For them, the horizon isn't a boundary but an invitation. Atlas embodies that ethos. It doesn't need a stable orbit or a permanent sun. Its identity is forged in the very act of crossing, of gliding between worlds. Philosophers debate whether belonging is a condition or a choice. Do you belong because you're rooted in a place, or because you accept your role in the flow of things? Atlas offers its own answer. Belonging doesn't require stillness. It requires continuity. The comet is not bound, but it is part of the galaxy's rhythm, just as waves belong to the sea even though none of them ever stop moving. You imagine lying beside a campfire watching sparks rise into the dark. Each spark is bright, brief and gone, but none of them seem misplaced. They belong to the fire even as they drift away. That's Atlas in miniature. A spark of another system flung outward, vanishing into the dark but still belonging to the cosmic fire that birthed it. The metaphor softens you, like warm hands pressing against your back, urging you toward rest. The comet's wandering also reframes your own. You're bound to Earth, yes, but Earth itself is a wanderer, orbiting the sun, which orbits the galactic center, which drifts within the local group of galaxies. Belonging isn't about stillness, it's about being part of the dance. Historians still argue whether ancient stargazers saw this, whether they intuited motion in the heavens long before heliocentrism was accepted. Either way, you're in good company when you let yourself see Earth as one more comet, one more traveller. And if Atlas can wander endlessly, why not you? Not in the literal sense. You're not about to fling yourself across space, but in the philosophical one. You can let go of needing fixed answers, permanent homes, or tidy conclusions. You can wander in thought, in imagination, in wonder, and still belong. That's the lesson tucked inside the pale shimmer of Atlas. Restlessness is not exile. It's participation in something larger. So you take a slow breath, and in your mind's eye, you walk alongside the comet. You don't need to know where it came from or where it's going. You just accept the companionship of motion. Two wanderers in parallel, one made of ice, the other of stardust wrapped in skin, both passing through a universe too vast to claim but too intimate to ignore. And as you let that image soften, you realize the paradox. The wanderer has no home, yet in wandering it belongs everywhere. Atlas isn't lost, it's simply free. And maybe, as you drift deeper into sleep, you can borrow a little of that freedom, letting yourself wander in dreams without needing a destination, secure in the knowledge that motion itself is enough. You let the comet's philosophy of wandering settle like dust in your thoughts, and then you lean into a grander vision. What if these interstellar visitors are not just curiosities, but a kind of galactic archive? Every fragment, every icy shard, every wandering rock carries a record of where it came from. Together, they form a moving library, a Milky Way museum written not on paper but in chemistry, mineralogy, and motion. To study Atlas is to flip through one page of an immense drifting book that spans light years and epochs. The idea isn't as fanciful as it sounds. When scientists study meteorites from Mars or the Moon, they decode histories, volcanic eruptions, magnetic fields, atmospheres long gone. In the same way, an interstellar comet is a sample of another star system story. Multiply that by billions of comets drifting between stars, and suddenly the galaxy is littered with archives, each one offering a different chapter. Some hold pristine ices, untouched since their system's birth. Others may have been scorched, carrying scars of close passes with alien suns. Together, they preserve a record of galactic chaos and creativity. History offers a parallel. The Dead Sea Scrolls, preserved by accident in caves for millennia, became an archive of voices we thought lost. Historians still argue whether they were hidden deliberately or abandoned in haste, but their survival transformed our understanding of the past. Interstellar comets feel like the Dead Sea Scrolls of the galaxy, accidental archives scattered widely, carrying stories we didn't know existed until we stumbled upon them. And here's a quirky tidbit. Some scientists speculate that certain isotopes found in Earth's crust, like traces of plutonium-24, may come from nearby supernovae or even interstellar debris delivered long ago. If that's true, then Earth itself already holds pages from this galactic archive, hidden in its rocks and sediments. You could say we've been reading from the library without realizing it, thumbing through cosmic footnotes embedded in our soil. The more you think about it, the richer the metaphor becomes. The Milky Way isn't a sterile starfield, it's a circulation desk, Every star system ejects material, and those fragments wander until they're absorbed by another system or dissolve into dust. Comets like Atlas are interstellar postcards, yes, but they're also microfilm reels, carrying detailed records in their molecular bonds. Even their trajectories are data, arcs that hint at gravitational encounters, star migrations, and galactic tides. You imagine future astronomers building catalogues not just of stars and exoplanets, but of the debris fields weaving between them. One day, perhaps, children will scroll through holographic displays showing samples from 12 nearby systems with cometary fragments analysed and compared. One icy shard might confirm that water is nearly universal. Another might reveal chemistry so alien it feels like science fiction. The galactic archive won't be shelved in neat rows, but scattered across the cosmos, waiting to be gathered piece by piece. Of course, the challenge is access. These archives don't sit patiently in caves. They streak past at tens of kilometers per second, here and gone before we can launch a probe. Historians still argue whether we should invest in fast response missions to chase such visitors or focus on long-term observatories to catch them more often. Either way, Atlas has already proven that waiting is not enough. The archive won't walk to our doorstep. We must run to meet it. The beauty of the archive idea is that it erases loneliness. You're not in a silent galaxy where every star minds its own business. You're in a galaxy where stars constantly share fragments, intentionally or not. Every system contributes to the library, scattering pieces that drift until another reader, human, alien, or yet unknown, picks them up. In that sense, the Milky Way is less a void and more a conversation, a dialogue written in ice, rock, and dust, and that thought soothes you in a way statistics never could. You're not an isolated observer staring out into emptiness. You're already part of a library in motion, with alien chapters floating through your sky whether you notice them or not. Atlas is one book among billions, but even a single book can change the way you see the world. So you close your eyes and imagine yourself walking through that archive. The shelves aren't wooden, they're streams of dust illuminated by starlight. The pages aren't paper, they're icy molecules glowing faintly in the dark. Every fragment is a story waiting to be read. And tonight, you've glimpsed just one. That's enough to lull you, enough to remind you that the galaxy is alive with memory. And even if you never hold the whole archive, you're already part of its circulation. One more reader in the vast, endless library of the stars. The thought of the galaxy as a drifting library lingers as you roll into the future. What tools will we build to read its pages more clearly? Atlas, fragile and fleeting, made it clear how unprepared we are. By the time astronomers spotted it, the comet was already brightening and already on its way to disintegration. What we need, you realize, are new eyes on the sky, sharper and faster than ever before, built not just to guard Earth from asteroids, but to catch these interstellar messengers before they fade. The flagship in this dream is the Vera C. Rubin Observatory in Chile, set to scan the entire visible sky every few nights. Its mission, the Legacy Survey of Space and Time, promises to catalogue billions of objects, turning the night sky into something like a time-lapse movie. If Atlas had arrived in Rubin's era, it might have been flagged earlier, studied longer, perhaps even intercepted by a spacecraft. The excitement around Rubin feels almost childlike. Astronomers whisper that it could revolutionize our sense of how crowded the galaxy really is. Historians still argue whether previous sky surveys underestimated interstellar traffic, or if we've just been incredibly lucky in spotting a few outliers. Either way, Rubin will test the question on a scale we've never attempted. A quirky tidbit: some astronomers affectionately call Rubin the Comet Catcher, even though its primary mission isn't comets at all. The observatory's massive digital camera, 3.2 gigapixels, the largest ever built, can snap images so detailed that if you photographed the entire sky, you could pick out a golf ball sitting on the moon. Imagine using that kind of power not for selfies, but for chasing cosmic snowballs from other stars. It's absurd and wonderful all at once. And telescopes on the ground are only half the plan. Space-based missions are in the works too. The European Space Agency's Comet Interceptor, launching later this decade, is designed to wait patiently in space until a comet, ideally an interstellar one, is discovered heading our way. Then it will spring into action, flying out to intercept and study the visitor up close. It's like keeping a camera crew permanently on standby, ready to chase down the next unexpected guest. NASA has mused about similar rapid response missions. The idea is simple in theory, but tricky in practice. Launch a probe quickly enough to rendezvous with an interstellar object before it escapes. The challenge is speed. Atlas, Oumuamua and Borisov all zipped through faster than any spacecraft humanity has ever built. Still, the dream persists because the payoff, an actual sample from another star system, would be the scientific equivalent of finding fire. Future detection won't just be about catching comets early, it'll be about context. Imagine combining telescope surveys with AI algorithms trained to recognize unusual trajectories instantly. Instead of weeks of debate, we'd know within hours that a new dot of light is interstellar. Alerts would ripple across observatories, and within days, spacecraft plans could be set in motion. The future of comet chasing will be less about sleepless scientists with coffee mugs and more about networks of machines handing the baton from discovery to analysis with breathtaking speed. You remember how in the early 20th century, astronomers used photographic plates to record the sky, often poring over them with magnifying glasses to spot moving dots. Now, supercomputers do the spotting, scanning petabytes of data in seconds. Historians still argue whether the human eye caught more subtle anomalies than modern pipelines allow, but the sheer volume of today's sky surveys leaves no room for nostalgia. The machines are our partners now, our sleepless scouts, and yet, even with all this technology, the magic remains. You can picture the next discovery, an astronomer staring at a monitor, heart racing as they realize the numbers don't lie. Another hyperbolic orbit, another trespasser. Within hours, headlines flash. Within days, telescopes worldwide lock on. Within months, maybe a spacecraft launches. The story begins again. The tools we're building won't just detect, they'll deepen. Infrared observatories like NASA's James Webb Space Telescope can analyze cometary chemistry with exquisite precision, catching spectral signatures invisible to the human eye. Future missions may plant sensors at the edge of the solar system, like sentries waiting to greet wanderers before they dive too deep. One day, perhaps, we'll build even larger skywatchers on the moon, free of atmosphere, scanning endlessly for the faintest flicker of alien debris. The dream is intoxicating. The next Atlas might not be a fleeting blur. It could be a well-documented visitor, analysed from birth to farewell. It might even carry fragments large enough to survive for decades, giving us time to launch, chase, and sample. The technology is within reach. The only question is whether we'll be ready in time. And as you imagine these tools humming into life, you feel oddly soothed. The future won't stop comets from fragmenting, but it will stop us from missing their stories. Humanity is preparing its nets, not to trap, but to listen, to catch the whispers of alien systems before they vanish into the dark. And maybe, just maybe, the next interstellar wanderer won't feel like a fleeting dream, but like a conversation, carried out in light, ice, and dust. You sit quietly with the thought of future telescopes and spacecraft, and then you let the story wind down as softly as the comet itself fading into distance. Atlas has already gone, its fragments scattering, its glow dimming into the same quiet darkness it emerged from. What lingers isn't the data alone, but the awe, the fragile recognition that we are tiny, yet we're paying attention. The final hush of possibility comes not from answers, but from the way the questions keep multiplying. Like stars spilling across the night sky. You think about the way Atlas entered, faint at first, barely a blur, then flaring into brilliance, then breaking apart. It feels less like a scientific event and more like a metaphor for life itself. Bright arrivals, brief flourishes, inevitable fragility. And yet, in its short visit, Atlas altered us. It joined the growing chorus of interstellar visitors, reminding us that our solar system is not an island. We're stitched into the fabric of the galaxy, part of a cosmic conversation written in orbits and dust. History gives the same reminder again and again. In 1543, when Copernicus dared to place the sun at the centre of the system, the world's perspective shifted permanently. Historians still argue whether his delay in publishing was due to fear of church backlash or simply academic caution. Either way, the revelation cracked open the humanity's place in the cosmos. Atlas, in its own faint way, nudges the crack wider, not in diagrams and heliocentrism, but in lived experience. It says, "You're not alone, the stars are sending fragments your way." And then there's the quirky tidbit. One astronomer jokingly called Atlas the comet that ghosted us, because it promised a grand show in amateur telescopes before crumbling into disappointment. The joke hides a tenderness. Yes, the comet fizzled, but in its failure it taught us more than 1,000 routine comets could. Sometimes it's the things that slip away, the stories that remain unfinished, that shape us the most. The final hush comes as you imagine Atlas slipping beyond our reach, fragments dispersing, tails dissolving into nothing. No one will ever see it again, and yet its existence lingers in our telescopes, in our debates, in our imaginations. The real gift isn't the fragments, but the perspective. The galaxy is restless, alive, busy with traffic. We are not observers in an empty room. We are participants in a vast and intricate dance. You breathe deeply, eyelids heavy, letting that perspective cradle you. Fragile though we are, we have the capacity to notice, to ask, to wonder. Atlas is gone, but it left behind a quiet awe, a reminder that possibility itself is infinite. The next comet will come, the next whisper will arrive, the galaxy is full, and we are awake to it. So as you settle into the hush, let yourself drift with Atlas, not clinging to beginnings or endings, but resting in the fragile beauty of passing through. You are a traveller too, orbiting your star, spinning on your world, carried by motions larger than you can feel. And in that endless motion lies peace,